the lesson that we're working on today is 11.4, which starts on 737. And we're talking about the Pythagorean theorem. And this should actually be review for you because Pythagorean theorem is something that you definitely should have done last year. So this should not be new, but maybe the way that we write the answers are, because in this chapter we're working with radicals. So some of our answers we're going to leave as radicals instead of changing them to decimals. I'll show you what we mean when we get to an example. The first thing you need to know about the Pythagorean theorem is that a squared plus b squared equals c squared. And that is true only for right triangles. And I'll tell you exactly what that means in a second. So if you have a right triangle, A and B are always the legs of the triangles. This side would be a leg and this side would be a leg. The two sides that meet at the right angle are the legs. They're also the shorter two sides. Now, it doesn't matter which one we call A or B. One of the legs has to be A, one of the legs has to be B. Okay? Now, this third side, the side that's opposite the right angle, that's called the hypotenuse. That's always going to be the longest side, and it's also always going to be considered letter C. So if you have a right triangle and you take A squared, so the length of A squared, plus the length of B squared, it will always equal the length of C squared. What we can use this for is to find the missing side of a triangle. If we only knew two of these, we could find the third side just by solving an equation. Remember, this only works for right triangles. Let me give you an example. Okay. Let's say that we have a right triangle, of course. Okay. And let's say that this side, we're just going to call it A. This side we'll call it 6, and this side we'll call 7. So we have a right triangle, but we're missing one side. You can use the Pythagorean theorem to find that missing side. We'll do a squared plus b squared equals c squared. Fill in the information that we know. We don't know the length of A, so we'll just call it a squared. We do know that b is going to be 6. This is the other leg because it meets at the right angle. 6 squared. And then c is always the side opposite the right angle. 7 squared. Okay. Now, this would be a squared plus 36 equals 49 if we do the squaring. We want to get a alone, so we're going to subtract 36 from both sides. We're left with 13. Okay. We'd like to get rid of the squared, so we have to square root both sides. And a equals the square root of 13. We can actually just leave the answer like this, like I was talking about before, since this chapter is about working with radicals. We're just going to leave them in radical form. Now, if this was a number that we could simplify the radical, then you should simplify it, because 13 is prime, you can't break it down, so this would be your final answer. Okay? The other thing that we need to talk about is something called the converse. Okay? The converse is when you take things and you can kind of switch it around, switch the order of the statement, and then take a look at the new statement that you're given. For example, if a squared plus b squared equals c squared, then it's a right triangle. So if a squared plus b squared equals c squared, then it is a right triangle. Is the converse of the Pythagorean theorem. Now, the Pythagorean theorem says if it's a right triangle, then a squared plus b squared equals c squared. Now, sometimes when you take the converse of a statement, sometimes the converse is not true anymore. In the case of the Pythagorean theorem, though, it is still true. The original statement, the original Pythagorean theorem, says if you have a right triangle, then a squared plus b squared equals c squared. That's true. The converse would be if a squared plus b squared equals c squared, then it's a right triangle. That is also true. Now this is useful if you have some information about the triangle and they want to know if it's a right triangle or not. What you can do is you can put it in here, see if this is true. For example, let's say that they give us the side lengths 8, 15, and 17. Okay? If they give us those 3 lengths and they ask us, is that a right triangle? Well, if a squared plus b squared equals c squared, then it is a right triangle. So let's check it. Remember, the smaller two are always a and b. So a squared plus b squared equals c squared. If this is true, then it is a right triangle. This is 64. This is 225. When you add 225 plus 64, you get 289. 289 does equal 289, which means that yes, this would make a right triangle. If these two numbers came out to not be the same, so it's untrue, then the numbers would not be a right triangle. So you can actually use the converse to check to see if things are a right triangle. Write down what questions you have. We'll do a couple more examples in class, and then we can go through your questions.